So, my name is Pascal Voury. I work at IDRIS, and I'm deputy head of the user support team in this center. So, why a site update? It's been a long time. The former one was in 2013, I guess, with the generation of machine that we still have up and running and that work really well, but are starting to be a little bit old, outdated. We just couldn't talk before because we just finished a new procurement with a new set of machines. And now I can talk about that without having any legal problem. I'll start with a brief overview of our ecosystem, nationwide and Europe-wide, because the way we're running procurements and the way we're working on a day-to-day basis is really a consequence of this ecosystem. You've heard the former speaker talk about Gen C. I'm going to explain a little bit what it is, because it's got a lot of importance. Then I'll restrain to my center, what we are and where we come from. Everything will be quite short, and I prefer that you ask questions if I'm too fast. My slides are full of informations, and I expect you to ask if I'm going through the slides very quickly, which I'm going to do. So what is the purpose of our new system? What are the main facts? Well, it's the first procurement done in France designed with HPC and AI convergence in mind. It's the first time we've got the mission to work in that direction. It's the first time we are going to have a light extension very fast, nearly a year after the machine will be installed. In fact, less than a year. It's a year from now, and we haven't got the machines yet. Oops. And it's also the first time we have to define a new environment for AI users. We understood that they couldn't work the way we used to work in a supercomputing center with batch classes, call for hours, and access for a year. And moreover, we have a strict regulation so that the projects compute a little bit each month and not everybody at the end of the year. And finally, we have to define a new access mode because, again, there are security constraints. We have to have the users go through security checks, and that is totally not possible for AI projects. So we defined another way to work, always with security checks, but organized a different way. What you won't learn here is what I like to do is the good, the bad, and the ugly. You won't know about the installation and the way it works because it isn't installed. The new machine is not installed yet. Okay, so nationwide and a little bit Europe-wise. Gen C in a nutshell. Gen C is what is really original in France. It's a privately owned company with 5 shareholders. All of the shareholders are government agencies. There is the Ministry for High Education, all universities and stuff like that, and research, which has the biggest part. The CEA, which is Atomic Energy High Commission, that has a big part of it. The CNRS, which is the French National Center for Research I'm working for, has another significant part. And the 2 last one are something that regroups the heads of the French university and a specialized institute for research in automatics and informatics. So what happens here is all those institute or commission or national centers put the money together and run a multi-year financing new machines every year. I go through that. Their main aim here is to have France invest on a regular basis, trying to cope with the rhythm of investment of other European partners. Their main aim here is the promotion of HPC among academics and industrials. Their participating in PRACE. The biggest machine in France is the one Tier 0 for France. Perhaps a lot of you are familiar with the pyramid that Gen C shows with first Tier 0 machines. We are, as IDRIS, a Tier 1 machine that doesn't participate in the PRACE projects, but we're giving a few, man hours to PRACE project 2. The director, the CTO of Gen C here is participates in the board of directors of PRACE. What's important here is it's participating in the European Processor Initiative here, also with PPIs for HPC that tends to buy storage on a European level too. Okay. So what's the situation nowadays? Gabriel Autreux from CNS explained to you that there are 3 centers. The one he works in Montpellier here, with a 3 petaflops machine. A brand new one for CEA, for atomic energy, that's dedicated for half to PRACE here, which is globally a 10 petaflops machine with Knight's Landing and Skylake stuff. That's pretty new too. It's now 10 petaflops, and the usual upgrade is going to be 20 petaflops in the beginning of 2020. What we're running at IDRIS in Orsay near Paris here is really what we're currently and still running is an IBM x86 and a Blue Gene, a 6 racks Blue Gene Q. And this is the procurement that we just finished, that we just gave its results with the HPE machine, starting with 14 petaflops. What's important here is that you can see that Gen C runs a real investment plan with new procurement nearly everywhere. This year that was IDRIS renewal. The extension is planned here in 2021. The aim is really what they achieved yet is really nearly a factor of 2 each year, increasing the power, the computing power. But there's going to be a little problem here because the Euro HPC projects aim to buy an exascale system, and this is going to be have a collision with the extension of the CNS renewal that's supposed to happen next year. I'll go very quickly through this slide. Why AI nowadays? If you put aside all the marketing stuff and stuff like that, it's really a political wish from the president of the French Republic, following the publication of a famous mathematician report that showed that we had in France a lot of scientists working at a very high level, but we have problem to retain them. So the idea was to try to go on generating new talents and retain the good ones that are already working. Maybe you've heard of Yann Lequin, that just received the Turing Prize a few days ago. So one of the ideas here, one of the things that have to actually be done is to have dedicated HPC facilities in France. And since we were running a procurement at that time, the ministry had asked Gen C to integrate this into the procurement that was already going on. So we had to have a very fast approach with results and not with actual results, and not ideas or marketing stuff. There was a working group set up by Gen C with IDRIS people from my team and AI experts, trying to reach the AI experts in France and to first to set up a benchmark, to assess the needs first, to then very quickly to set up benchmarks so that they could be integrated in the procurement, in the call for tender that was going on. And then we worked defining the way all those people could access to the machine. Of course, there's been some work, and of course, there's been work going on about containers. So what is IDRIS? I said not in a nutshell because I'm going to have a few slides, but again, I'll go through them quite fast, and you'll tell me if you have questions. If you look at the lights, Paris is about there, and we're a few tens of kilometers outside of Paris in a green valley. That's pretty nice. But that's changing a lot because there's been a lot of money invested by the government to set up something, to gather all research center, whether they're academics or big companies like EDF, for example, gathering at the same time. So around Orsay here, there's a project to run some sort of Silicon Valley in France. They're trying to build up some kind of energy like that. The teams, very quickly, we're not a big number of people. The two main systems are the systems and operation team and the user support team here. And it's a mix between people working on long-term contracts and people on short-term contracts. What's really original in our organization, and something that attracted me there a few dozen years ago, is that it's really, in our team, we're really working on a flat organization. Comparing to other big supercomputing centers, we don't have different level with a help desk talking to the users and other engineers working high-level stuff. It may look like a waste of time or a waste of energy, but in fact, the small problems are solved very quickly. And according to the figures we have here, for the last years, for half a dozen years ago, we have 7,600 problems that were solved, and a fourth of them are really important problems that would last for a few days or a few weeks, like debugging very big applications or doing some optimization or enhancing parallelism, actually. Since we have, let's say, around 300 projects and a little bit more than 1,000 users, we've got people from all the academics, and we have a very wide diversity of applications, and that allows us to work a lot with the people from the compiler teams, whether it's IBM formally with the XLF compilers, or more recently Intel with our 886 actual machine, or PGI, since we're working on our prototype with the PGI compiler. That's quite a lot of work. Of course, we install libraries and dedicated software. That's not something that's not a lot of work. We find that documentation is very important for the users. And at least we're really making a lot of effort to have a clear documentation. For everything we do, the aim is to have our users being as autonomous as possible. Some of them want to be helped, some of them don't want to read the documentation, but as far as we can do, we do as best as we can to have the documentation as clear as possible. And it seems to be quite successful, since we have a lot of files and a lot of info going on, and we have a lot of access too. January is not the best period to look at the access because of the start of the year. And of course, this work has to be done each time a new generation of machine arrives, since we're documenting even the way to submit jobs and stuff like that. So what our aim is to be a center of excellence on programming languages. And the way we're trying to do that is to give a lot of courses. Of course, we do work by ourselves, but we give a lot of courses at IDRIS. We have 10 different offers that are repeated during the year. All in all, for half a dozen years, we've had 150 sessions and more than 2,000 attendees. Some of them from praise training centers, what used to be PATC, but not that much. Different for us is the courses have to be done in English, and we're not used to that. But what we see too is that our courses are downloaded by people that cannot come and access to the courses. There's a very good rate of courses downloaded. We insist during those courses to have things mixed between theory and lots of hands-on. It's roughly half-half. So it's something very interactive. Thanks to Gen C working to prepare the call from tenders, for a few years now, Gen C buys prototypes. There are 3 of them. Oh, strangely enough. Yes, there are three of them. And thanks to that, we were able to start working a little bit in advance on GPU accelerated parallelism, testing the compilers about the latest versions of OpenMP norm and developing our knowledge with OpenACC. Of course, we are also involved in European projects, since everything that's related to praise we've been involved in since the start, because our site was a lot of tens of years ago started the first European projects. What we're doing now, preparing for new installation, we've always on an individual basis did technology watch. This is something that's quite obvious for our job. We need to know where we're going. Very recently, Gen C set up a technology watch task force that buys prototypes, the way I just told you, and helps defining benchmarks for the future call for tenders. And those prototypes nowadays are a KNL that's installed in Montpellier, in south of France. We are running an OpenPower plus NVIDIA prototype. The prototype that started the work on PlantNet, Gabriel told you a few minutes ago. And there's an ARM prototype that's installed at CEA. Among the special duties that we're currently running, we're insisting about a special task for AI priming and user environment definition. It's really something that we have to design from scratch, and we don't have room for failure here. Of course, we're running some kind of medium-term projects. Some of them are really for our own use. We're installing Jenkins and SPAC on prototypes for new machines. And there's something really brand new here. It's called contrat progress, sort of progress contract. I don't know how to call it in English. A set of 6 user codes that are supposed to be representative of the workload of the actual machines are selected for acceleration improvements, and we've got a year to have multiple of 4, 5, 6, depending on the code. We're supposed to accelerate them on GPU, and we have a year from now, even if the machine is not installed, to achieve those acceleration on our new machine, so that new money could be invested to buy more GPUs, more nodes, etc., etc. Saying that we're a center of excellence is something. It could be marketing, but there are actual achievements that can be seen. This is the workload depending on the different user communities that we had on Blue Gene 8 years ago. You can see here that was plasma and theoretical physics that was having nearly 3/4 of the machines. And 8 years later, on the Blue Gene Q, you can see that everything is more much better spread among communities. And this is really because we worked a lot with our users on hands-on sessions, starting on Blue Gene P, of course, at the time, but going on Blue Gene Q. Another achievement that's quite impressive here is the scaling with the same hands-on session on the Blue Gene, on our massive machines. The results we've had between 2014 and 2018. Here is the number of cores that are involved in the calculation, and the percentage here is the percentage of the total hours that were computed in our center. I'd start with the Blue Gene Q. You can see that the maximum hours were was eaten by people computing on maximum 8,000 or at best 16,000 cores. And 4 days later, all these things shifted, and we multiplied by 4 the number of cores that are mostly used on your machine. Our machine is 100. This is mainly around half of the machine that is used by regular codes running on the machine. And this is something we're pretty proud of. So coming back to the procurement, I had fun finding an image of the machine room. It's really a quarter century ago. It was our site was funded in 1993, late 1993 and beginning of 1994. For those of you that were in the business at that time, these are Cray C90 series. There isn't the T3D that we started installing then. And up there, you can recognize a convex machine that used to be our archive machine. Its only work was to have the storage tech silos here. We had multiple of them, and the only work of the convex was to take care of the transfer of the data between the silos and the computers. So this is sort of a resume of the machine we installed since then. You can see that we started with vector system. Quite fast, we had a sort of a dual hardware configuration, since we very quickly bought T3E, the Cray T3D first, with parallel SCADA systems. And then we went on with the IBM systems, starting really with something important with the Power 4. The vector system ended in 2012. Our Power 4 started in nearly at the beginning of the 21st century. And even before we stopped working with vector system, we started installing. In fact, I should have done another column here with massive parallel systems, because Blue Gene P and the Power, even 4 Plus or Power 4, those machines have much more nodes. Those machines have much more nodes. For example, with our current generation, these are the machines we're running nowadays. These machines have around 10,000 cores, and the Blue Gene Q here has around 100,000 cores. So it's really a difference in programming and the way you're using them. So I should have made a massive parallel column here. And the procurement ended with buying a HPE machine. The machine is called Jean Zay. This guy is a famous public servant. He helped define the research in France before World War II, and he worked with a deputy Jean Zay didn't survive World War II, but the person he was working with, his deputy, went on working after World War II and founded the National Center for Research that I'm working for. This year, it's the 80th anniversary of this this creation, and that's why we honored, we paid tribute to Jean Zay, naming the machine after him. What's original here, what's different here from what we do usually is that we have two partitions. There's a standard, I would say, scalar partition that's around 5 petaflops, and there's a converged partition with GPUs that's around 9 petaflops when we install them. So what do we have here? We have 1,500 dual socket nodes, all of them being Skylake. Each socket has 20 cores. What's interesting here is that from what we see, whether it's A6 or the Blue Gene machines we have, each time you increase the number of cores, the memory per core decreases. And we're used to have, on x86 machine, we used to have something like 3.5 gigabytes per core. And on this machine, on the contrary, we're increasing the memory per core, even if the number of cores increases. There's been a huge effort here to bring a lot of memory to the codes we're running. And there's an OPA link for each node. So the converged partitions the base is the same with 260 nodes, dual socket nodes, but each node has 4 NVIDIA Volta and 4 OPA links to increase the bandwidth between the nodes. On the storage side, sorry, I've been a little bit faster. On the storage side, we keep the GPFS system. We've always had GPFS as sort of a standard storage in the middle of our parallel and massive parallel systems. They always have been a standard storage between the two of them, and we're just sticking to GPFS now. Spectrum scale. The difference is, for the first time, we bought 1 petabyte full flash disks from DDM. Bandwidth is 300 gigabytes sustained. We don't care about the peak performance. And a second level of hard drives is planned at the end of 2019, maybe 2020, we'll see. This is a procurement state going on. The machine looked like that. I wish I could have showed you a fancy image with fancy colors, but I'm not allowed to show it to you yet. It's still under definition. And we're supposed to enter full production in October. That means that we would have run every performance verification until then, and the 3 months we're running the grand challenges on the machines have to end before that. There is a light update I was telling you about that's related to code performance conditions, and we'll buy a few hundred of GPUs. But what's interesting is that maybe we'll buy nodes with more than 4 GPUs per node, or more OPA links. We don't know. It will depend on what we find here. We may have specialized nodes, either for IA or for computing, depending on the performance we achieve on our tests. As a conclusion, this procurement is really a series of first time. It's the first converged machine in France. We're starting from scratch with GPU acceleration. If I rewind to the generation of machine, you can see that, on the contrary, with other sites in France and in Europe, we never bought GPU stuff. We were never convinced by the performance you could achieve with a whole bunch of different codes from different academics, from different groups of users. The situation changed with the latest versions of OpenMP, and we now believe that we can achieve performance with GPUs. However, we have to get our own experience about that, and we have to test drive the compilers and the way we are going to really achieve those performance. We are also starting from scratch with AI. Gen C was very important, played a very, very important role here, buying a prototype that allowed us for a little bit more than a year and a half working with AI. Gabriel told you that the special project he was telling you about started at IDRIS. That's a fact. It's been part of the early access users that are allowed to use our prototypes and bringing us that knowledge. As we're helping them, but they're giving them their knowledge too. And this is very challenging because we also have to design an environment for those users that's totally different from what we've been used to for years. So it's not a new mission, but it's really reinforced, and we have the difference is we also have a lot of political pressure. We have to succeed in this mission. We're being monitored this time, sort of. Okay, thank you for your attention. I'm glad to answer any question if you have. Well, thank you very much.